Hi, I'm Jennifer Pulley, your host, along with Dan Giroux, who's joining us remotely from the NASA Langley Research Center in Hampton, Virginia. You know, we're real excited to be here at the U.S. Space and Rocket Center in Huntsville, Alabama, for part of this NASA Connect. Teachers, make sure you have the educator guide for today's program. It can be downloaded from the NASA Connect website. In it, you'll find great math-based hands-on activities and information on our instructional technology components. On this episode of NASA Connect, we're visiting NASA Marshall Space Flight Center in Huntsville, Alabama. There, we'll meet NASA scientists and engineers who are exploring the challenges of building the next generation of reusable spacecraft. My friends here are going to help me figure out what it takes to get into orbit.
How can we do that?
By learning how NASA is getting spacecraft into orbit more safely and less expensively.
Can't we just keep doing it the way we always have?
Well, you know, things change, and we need to change in order to continue our journey of exploration. Just think, we went from the Wright brothers' first flight in 1903 to landing on the moon in 1969. As you can see, people have been dreaming of flight for ages. One of those dreamers was American Robert Goddard, an early experimenter with rockets. His work continues to inspire generations of scientists. These rockets are the results of Goddard's and other pioneers' imagination and hard work. Now, it's your turn. You are the next generation of space explorers.
Whoa, that's way cool.
I know, it really is, Zach. And you know, just as the early space programs of NASA like Mercury, Gemini, and Apollo led us to the shuttle leads us to the next generation of spacecraft.
What's that?
That's what this show is all about, Seema.
All right. Okay, I'm pumped. But how do we get these heavy rockets off the ground?
You know, Zach, that's a really good question. And what do we mean by the word heavy? Well, what we call heavy is just a way of measuring gravity. Gravity is a force of attraction between objects. Everything in the universe is attracted to everything else. Sometimes it's powerful, but sometimes it's weak. The amount of attraction really depends on the mass of the objects.
Mass? Drinks more than everyone. You owe me a soda.
Hey, Zach, pick Cassie and I up one too. Mass is not the same as weight. Think about how astronauts become nearly weightless in space. When they are on the moon, they weigh only 1/6 of their weight on Earth. For example, a man who weighs 180 pounds on Earth would weigh 30 pounds on the moon. They didn't shrink, did they?
Their mass is the same, so what causes their weight to change?
Gravity. The force of attraction between objects. On Earth, we feel gravity because of Earth's mass. Weight is just how we measure gravity's pull on things. In space, gravity is less because we are further away from the Earth's mass. The further away from a large mass like our Earth, the less gravity, and therefore, the less weight.
What does this have to do with building spacecraft?
Everything, Zach. The mass of a spacecraft determines its weight. And the more a spacecraft weighs, the more force is needed to reach orbit.
Force? I thought we were talking about gravity.
Okay, I think we need to talk about some basics here. Lucky for us, 17th century English scientist Sir Isaac Newton explained the relationship of mass to gravity. He said we need force to overcome gravity. Newton described this relationship as a series of laws. Newton helped our understanding of gravity with his first law. What Newton said is easy to understand. An object at rest will stay at rest unless a force moves it. With a spacecraft, we need to come up with the force to move it.
So we need to keep the mass low, right?
Correct. Keeping the mass low will mean less weight at launch. The force of gravity on the spacecraft is equal to the force of the launch pad holding it up, what Newton called balanced forces. We have to unbalance these forces to move the spacecraft.
How do we do that?
Well, Cassie, Newton explained in his second law that if a force is applied to a body of mass, the body will move in the direction of the force. Newton also described in his third law that for every action, there is an equal and opposite reaction. The thrust of a rocket motor is the action. The reaction is the spacecraft leaving the pad. Thrust measures the power of a rocket engine. The thrust must be greater than the force of gravity that keeps a rocket on the launch pad. For example, if the thrust, T, of a rocket is 75 kilograms and the weight of the rocket, W, is 50 kilograms, then subtracting 50 from 75 would equal 25 kilograms of upward force, F. To get into orbit, you need to keep the upward force greater than the force of gravity. When you ride an amusement park ride like the Space Shot here at the Space and Rocket Center, you are overcoming gravity as you rise up. At the top, you experience free fall or microgravity, just like the astronauts. You just don't stay in free fall very long because you drop back downward as the downward force of gravity becomes greater than the upward force.
That was awesome!
The force of gravity is measured in units called Gs. At sea level, that force equals 1 G.
So we need more than 1 G of force to move the rocket?
Pretty much, Seema, but it's not as easy as it sounds. Let's take the Saturn V rocket of the Apollo program. Now, how much do you think that rocket weighed at launch? Remember how fast a spacecraft needs to travel in order to reach orbit.
Yes, 17,500 miles per hour.
Correct, and that's over 28,000 kilometers per hour. The Saturn V is taller than the Statue of Liberty and weighed over 6 million pounds at launch. The Saturn V's engines had to produce over 7.5 million pounds of thrust to have enough upward force to overcome the downward force of gravity.
Okay, I get it. If we keep the weight of the rocket down, we won't need as much engine thrust to move it.
Right, you guys are so smart. You know, engineers deal with this all the time. They use math to compare the vehicle weight to the thrust of the engines. Now this can be written as a ratio. And a ratio is just a simple way of comparing one thing to another. In this case, vehicle weight compared to thrust. So let's talk about the Saturn V. Let's say it weighs 1 million pounds and it produces 1 million pounds of thrust. The ratio for that would then be
1 to 1 and wouldn't go anywhere.
But the Saturn V engine created 7.5 million pounds of thrust and the vehicle weighed 6 million pounds.
Yeah, so that's a ratio of 7.5 to 6. Or let's see, 5 to 4.
Exactly. Now you see how important it is to build rockets more lightweight. A couple of ways NASA scientists and engineers tackle this problem is by using lightweight materials and designing more efficient engines. Today, NASA is working on the next generation of reusable spacecraft, or launch vehicle system. We call it the Space Launch Initiative, or SLI for short.